logarithm, we can write in exponential form 4 raised to minus 1 equal to x. So value of x is 1 by 4. We will discuss this example on presentation. First we have assumed log base 4 of x equal to y. So we can write x equal to 4 raised to y using definition of logarithm. And the question is given x raised to log base 4 of x equal to 16x. So replacing value of x, that is 4 raised to y, and we have assumed log base 4 of x equal to y. So we can write 4 raised to y equal to 16 into 4 raised to y. That is 4 raised to y square equal to 4 square into 4 raised to y. 4 raised to y square equal to 4 raised to 2 plus y, using this property a raised to m into a raised to m. Base is same, so we can add power. So comparing the power on both sides, we will get y square equal to y plus 2. So y square minus y minus 2 equal to 0. That will give you y minus 2 or y plus 1 equal to 0. So we are getting y equal to 2 or y equal to minus 1. Replacing value of y equal to 2, so we will get value of x, that is 16. If y is minus 1, we have assumed y is log base 4 of x equal to minus 1. Apply definition of logarithm. So we can write x equal to 4 inverse 4 raised to minus 1, that is x equal to 1 by 4. Now try some on your own for your homework. Note down the question. If log base 10 of x over b minus c equal to log base 10 of y over c minus a equal to log base 10 of z over a minus b, then prove that x into y into z equal to 1. Second question is log base b of a into log base c of b into log base a of c equal to 1, and second equation is log base b of a square into log base c of b cube into log base a of c raised to 4 equal to 24. Now we will discuss application of logarithm where log is used. To find the number of payments on a loan or the time to reach an investment goal. To model many natural processes, particularly in living systems, we perceive loudness of sound as the logarithm of the actual sound density, sound intensity, and decibels are a logarithm scale. We also perceive brightness of light as the logarithm of the actual light energy, and star magnitudes are measured on a logarithm scale. To measure the pH or acidity of a chemical solution, the pH is the negative logarithm of the concentration of free hydrogen ions. To measure earthquake intensity on a Richter scale, logarithm is used. To analyze exponential process, because as we know that logarithm function is the inverse function of exponential function, so we often analyze an exponential curve by means of logarithm. To solve some form of area problem in calculus, logarithm is used, as the area under the curve 1 over x between x equal to 1 to x equal to a. The answer will be ln a, that is natural log. Now we will see application of logarithm on video.
Logarithms in the real world. Over the past 30 years, the active use of logarithms in math has gone down due to the availability and use of calculators, and secondly, the availability and use of computers. It used to be in textbooks and scientific journals, long directories of tables in these reference books were devoted to providing logarithms to make multiplication and division a lot easier. Logarithms were used in slide rules, the computations tool that got men to the moon. The great value in logarithms today is that they can be used to make a sort of shorthand or code to make extremely large numbers manageable and understandable. And they are especially evident in science and in measurement. Even though there's not a popular logarithmic scale for it, our sensitivity to light is highly logarithmic in how we perceive stimulus or output. The amount of light from direct sunlight, about 100,000 lux, is 1 billion times more or brighter than the light from the brightest star in the night sky at 10 to the negative fifth lux. Between the eye, with the iris to adjust the level of light, and the neural signal transmission of the brain, human vision is able to adjust to span wide extremes in light input amounts. The intensity of earthquakes is measured by a number on the Richter scale. The Richter scale is scaled to a base 10 logarithm. For instance, a 5.0 earthquake has twice the shaking amplitude as a 4.0 earthquake. And logarithmic scaling also gives us a measure of acidity. And here we have a chart that shows pH. The pH of a solution is determined by a logarithmic function relating the hydrogen or H plus ion concentration in a liquid. Logarithms are used to describe sound intensity in decibels. The smallest sound a human can hear is defined as the threshold of hearing, or TOH. That volume is defined as 0 decibels. Every sound can be classified in decibels according to a base 10 logarithmic scale. Every multiple of 10 from the threshold of hearing translates to an increase of 10 on the decibel scale. For instance, a vacuum cleaner sound at 8 decibels is 10 times as intense as busy street traffic sound at 70 decibels. And here are some sound intensities. And here we've highlighted whisper versus normal conversation. Now, whisper is 20 decibels, and a normal conversation that might be able to be heard across a quiet room would be 60 decibels. Now, 60 decibels versus 20 decibels is 40 decibel difference, and that translates to 10 to the fourth power more energy intensity for that normal conversation, or 10,000 times as much energy intensity in that sound between a whisper and normal conversation, highly logarithmic. Now, the light intensity of stars, planets, and comets is classified by magnitude. In 1856, a system for rating intensity was devised where 0 magnitude light source is 100 times as intense as a 5 magnitude source. So every increase in magnitude is a multiple of a fifth root of 100. And here we see that every increase of 1 in magnitude is really about a 2.5 factor of increase in brightness. Logarithmic functions are used to calculate ages by radioactive dating. An order of magnitude is an exponential change of plus or minus 1 in the value of a quantity or unit. The term is generally used in conjunction with power of 10 scientific notation. Now, based on the definition, anything that is 10 times as much of something would be 1 order of magnitude higher. For instance, $1,000 would be 1 order of magnitude greater than $100. Log base 10 or log subscript 10 is sometimes called the common log. And why is that? Well, as humans, we have 10 counting digits on our hands. That's an explanation for why we use a base 10 number system today. Now, maybe aliens in a different galaxy have a different common log than base 10. Maybe this guy in his alien species uses a base 8 as a common log. Now, in our graphing calculator, there are 2 keys that represent logarithms. The common log or log key, highlighted here, and below it, the ln key. The ln stands for natural log and has the irrational number e as a base and has properties that will be covered in pre-calculus and in calculus courses. Now, you can find the common base 10 logarithm of a number by pressing the log key, then the number you want to evaluate, then press enter. Here we have log of 10,000 equals 4. And what is being calculated is the answer to the question, what is the power 10, or 10 is the base, what is the power that 10 needs to be raised to equal 10,000? Well, here we see it's 10 to the power of 4 equals 10,000, so we say that the common logarithm of 10,000 is 4. We hope this video as an introduction has been enjoyable. Come back and see the other videos that go into logarithms a little more deeply.
Okay, this is end of the topic logarithm. Now we will start new chapter, that is trigonometry. First we will say introduction. Trigonometry is derived from three Greek words. Tri means three, goni means angle, and metro means measurement. It means measurement of angle, measurement of triangle. Trigonometry is the branch of mathematics which deals with triangles, particularly triangles in a plane where one angle of the triangle is 90 degrees. Trigonometry specifically deals with the relationship between the sides and the angle of triangles, that is on the trigonometric functions, and with calculations based on these functions. Let us see history of trigonometry. The origins of trigonometry can be traced to the civilization of ancient Egypt, Mesopotamia and the Indus Valley more than 4,000 years ago. Some experts believe that trigonometry was originally invented to calculate sundials, a traditional exercise in the oldest books. The first recorded use of trigonometry came from the Hellenistic mathematician Hipparchus circa 150 BC before Christ, who compiled a trigonometric table using the sign for solving triangles. Many ancient mathematicians like Aryabhatta, Brahmagupta, Ibn Yunus and Al-Kasi made significant contribution in this field. Trigonometry was originally created by the Greeks to aid in the study of astronomy. Hipparchus of Bithynia 190 to 120 BC before Christ tabulated trigonometric ratios to enable the calculation of planets' position as formulated by Apollonius. Let us discuss angles and their measurement. That we will discuss by practical. What do we mean by angle? Say, if you see, this is one ray. If you can observe, this is one ray. If I rotate this ray along at end points, see, this is the motion of ray. And after this rotation we are getting another point, and if you see the position of another ray, this ray is an initial ray and this is a terminal ray, and the measurement that we are getting is nothing but an angle. If we rotate this ray along in an anti-clockwise direction, then the angle that we are getting, it is a positive angle. If we rotate this angle in a clockwise direction like this, if you see on the screen, then the angle is negative. Now if we rotate this angle in an anti-clockwise direction like this, if you see on the screen, then whatever the measurement we are getting, this is nothing but angle. This angle is 90 degree. See, and if we rotate like this, then the half circle will be over and we are getting 180 degree. Again we are rotating this, so we are getting 270 degree, and complete revolution will give us 360 degree angle. If this angle is 90 degree and it is known as right angle, if angle is less than right angle like this, then it is known as acute angle. If angle is greater than 90 degree, then it is obtuse angle. The same we will discuss on presentation. Angle is formed by joining the end points of two half lines called rays. Measurement of angles. This is, if you observe, the same thing we had discussed by practical. OA is the initial ray and OB is the terminal ray after rotation of initial ray, and whatever the measurement we are getting, that is nothing but an angle. Angle is considered as the figure obtained by rotating initial ray about its end point. Measurement and sign of an angle, measure of an angle, and amount of rotation from initial side to terminal side. Sign of an angle. If we rotate initial ray in an anti-clockwise direction, then the angle that we are getting is positive. Remember, again I am repeating the sentence. If we rotate in an anti-clockwise direction, then the angle that we are getting is positive, and if we rotate in a clockwise direction, then the angle is negative. What is right angle? 1/4 part of a circle, as we had discussed in the practical. This is 1/4 part of the circle, and this is the angle that we are getting is 90 degree, and complete revolution gives 360 degree angle. Revolving ray describes 1/4 of a circle, then we say that measure of an angle is right angle. If angle is less than right angle, then it is known as acute angle, and if angle is greater than right angle, then it is known as obtuse angle. Let us try to understand quadrants. X dash OX is nothing but x axis, y dash OY is a y axis. In first quadrant, x and y both are positive, as you see on the screen. In second quadrant, x is negative and y is positive. In third quadrant, both are negative, and in fourth quadrant, x is positive and y is negative. System of measurement of angle. Measurement of an angle, there are three systems. First is sexagesimal system. It is also known as British system, or it is also known as degree measure. Another is centesimal system or French system, and third one is circular system or radian measure. System of measurement of angles. First is sexagesimal system. It is also known as British system or degree system. If the rotation of the initial side to the terminal side is